ज्वाइन तो करो. Ayo, coming. Good evening, Sarthak, Kavya, Nandini, Abhirami, Rahul, Yaini. I didn't put live in that, and I was waiting. Now look here. Where is Madhumita? Such a stupid person. Good morning, beta. Now listen. Very important thing. We are not going to waste time. I'm just going to teach what is electric motor. Okay. What is electric motor? I'm going to teach Rahul. What miracle happened, Rahul? Madhu, good evening, good morning, beta. Good evening, I'm saying. Now look here, beta. What is electric motor? If somebody will be asking you what is electric motor, then you have to say that it is just an electrical machine. You might be seeing that motor is available everywhere. Available everywhere means a small motor to bigger motor is there. Then we know that this motor is exactly used where? This is exactly used for mechanical work. So what is exactly that mechanical work? Okay, shall we start our work? That is the biggest miracle, Rahul. Okay, so now that means first if somebody will be asking you what is electric motor, then what answer you are going to give? You are going to say that it is exactly an electrical machine that converts electrical energy into mechanical energy. Your washing machine, your toaster, your mixer grinder, everything is having a motor and it works with that motor. It works well with that motor. Okay, it works well with that motor. Fine. Now we are going to talk about how the motor is exactly working. Okay, so now all these things are waste of time. We are going to go towards the most important thing, the entire working of a motor. We are just going to understand the entire working of a motor. We are going to understand just one small thing. Starting part itself, I am going to start. What and all contents are there? See, we know that when a wire is conducting current, then if the wire is allowing current to pass through it, with current what is exactly moving in the wire is magnetic field around it. So that means a wire itself forms an electromagnet. Point by point I am telling you, we have to just go with that sections. Okay, so that means a wire which is allowing current to pass through it will have magnetic field around it. So that means electromagnet is ready. First concept. A wire which is allowing current to pass through it will have magnetic field around it. So that means an electromagnet is there. Now when a wire will have a magnetic field and it will go near to a magnet, then magnet can do two work. If the magnetic field of wire and the magnetic field will be parallel to each other, then they will not repel each other. But when they will be coming in field of each other, as we know that magnetic lines of force never intersect each other, that time they will be repelling each other. I repeat, they will be repelling each other. Okay, that means the electric current magnetic field lines, if it will come intersecting with the magnetic field lines, then they will start repelling each other. Today these concepts are going to be very important for your examinations, so listen to me very carefully. Okay, so that means the magnetic field. So if somebody will be talking to you that okay, this is the magnetic field around a wire. Okay, the magnetic field around a wire, I am just doing a rough sketch. So now here a magnet is there. Now this magnet will also have its magnetic field. So if they will intersect, will they be able to allow to intersect each other? The correct answer is no. They will never allow to intersect because magnetic field lines are never intersecting. And the answer also I have given you why magnetic field lines are not intersecting. Two tangent points are not possible. Two tangent line for one point is not possible. It is a straight away not possible. So we are not going to talk about, because already in past we have discussed much about it. Okay, so that means two lines of force of magnetic field will never intersect each other. The lines of force of magnetic field will never intersect each other. This is a very important point. Fine. Now we are going to go to the next section. We are going to understand how an electric motor is made. The concept you have to understand, working and principle and formation, everything we are going to discuss. Okay, good morning Kamya. Now first work is, we are going to take a rectangular coil. Now this rectangular coil is a conducting coil. Conducting coil means it is exactly, always we have seen a circular loop, a straight wire, but this time we are taking a rectangular coil. Fine. Now here a very pure concept of Fleming's left hand thumb rule will be used. So now we are going to understand how we are going to use here, good morning Renu, how we are going to use here Fleming's left hand rule, because I am specifically explaining, so I may not be able to see the chat box because it is right now. Then Kamya, okay, so now listen. Here what work we are going to do is, we are going to understand how current will be passing. Now the most important point is, this one is exactly called as axle. The center point with which it is connecting is called as axle. Now with axle, what will be there is commutator. Commutator will be there, carbon brush will be there, okay, and a circuit will be there, and the circuit will have current conducting in that. Okay, so that means the circuit will allow current to pass through it. Now concept by concept you have to understand, because many children, they are having the concept that it will rotate like this, it will rotate like this, or it will rotate like this. What will be the rotation? Where will be the force? Where will be the current? This is the confusion. So now I am just going to clear the confusion one by one. So first work is, when we will allow, so you first have to understand that this is commutator. The commutator will always have a gap in between them. So just understand, commutator looks like this. It will always have a gap. It will always have a gap. So now this commutator is exactly a rotating commutator, and it is exactly resting on an axle. Okay, the central line, if it will be checking, it will be the axle. The commutator is attached to the axle. Fine. The commutator is attached to which one? Axle. Now commutator will have a gap in between them. Fine. Now this commutator is attached with a wire. That wire is rectangular in shape. This is exactly called as rectangular coil. For your class, it is important to understand what is the working of this wire. Okay. So now what is happening here? In short, we have to discuss that first is, the current will start moving into this. Now Fleming's left hand rule. So you already know that what will happen for Fleming's, because you have to understand, once this wire will have current in it, then it will have magnetic field around it, and this wire will act as an electromagnet. So magnetic field ready, electromagnet ready, then magnetic field lines will also be there, and these magnetic field lines will start interacting with each other, and either it will repel or it will attract, or it will not influence each other. So when two magnets will not influence each other, when two magnets are kept like this and both magnets are parallel to each other, then they are not going to trouble each other, because their magnetic lines of force are not going to intersect each other. Okay, problem will be when two magnets are like this. Problem will be when magnet placement is like this. Now both will have same pole, then they will repel. But the moment I will do like this, now the magnet will attract. The magnet will attract. So this is the simple concept. Fine. So here also same thing happens. This wire will have magnetic field. This magnet is having magnetic field. Now how the magnetic field is moving? See, this magnetic field is moving from North Pole to South Pole. Okay, this magnetic field is moving from North Pole to South Pole. Now this wire magnetic field will be there. So now where will be the force? Where will be the magnetic field? So you have to understand that when the current will be moving in this direction, okay, then magnetic field will be exactly intersecting into this place. So that means according to Fleming's left hand rule, you can see like this. So where will be the current? The current is exactly going up. So once the current is exactly going up, then force will be down. magnetic force, the field, the force which the magnetic field is generating, which will be down, because suddenly what will happen? So the magnetic field, the force generated by the magnetic field will let the coil move straight. Okay, so that means after some time the coil mouth will go down, here B will come, here A will come, C will come, and here C will come, and here D will come. So that means the movement, the current will start flowing into this, that particular movement, the magnetic field will be generated in the wire, and once the magnetic field will be generated and this magnetic field, they will repel each other and it will just push it like this straight. It will make it straight, and once it will make it straight, then again it will be starting. Then you will say that, auntie, current is exactly moving. So what is the direction of current and what is the direction of force? So the most important thing is, already we know that magnetic field will be generated by both the coil and the magnet. Magnet so definitely going to generate a magnetic field. The coil will also generate a magnetic field. Okay, so now what will happen? The direction of force will be down there, and current direction is this one. Now you have to point this at the time of writing the working. You have to indicate this very important point, that ki, okay, the current is moving in this direction, so the current is moving in this direction, so force will be acting downward. Now the current is moving in this direction, force will be acting downward. Now next is, if then current is moving in this direction, can you tell me the direction of force? If you are listening me very nicely, then tell me this side, what will be the correct direction of force? Down or up? Down or up? Tell me fast. Down or up? So when current is moving this direction, according to Fleming's left hand rule, here Fleming's left hand rule is applicable. So very good, Kaushika. So it will go up. So if the force is exactly, one force is going down, one force is up, then definitely it will push it like this. So it will move anti-clockwise. Which direction it is going to move? It is going to move anti-clockwise. It will not move clockwise, it will move anti-clockwise. And after one, then you will say that, auntie, when it is exactly moving anti-clockwise, then this commutator will also move. See, look here, the commutator will definitely move like this, because carbon brush is a free attachment, and this carbon brush is exactly fixed to the rotating commutator. Okay, so this rotating commutator, when it will be not working, it will have like this. Okay, it will have like this, but the moment that rectangular coil will move, the commutator position will change like this. Very good. The commutator position will change like this. So the moment commutator position will change like this, now the carbon brush is exactly connected to the circuit. Because there is a complete detachment for a minute. Okay, why? Because the complete detachment for a minute, I am saying, because see, the commutator, if there will be exactly, the commutator will be circular. Why I am talking about gap? Because if the commutator will be circular and it will be connected to the wire, and then what will happen? The commutator will exactly, the coil the wire it will start rotating on the this commutator only. So everything will exactly, the wire got wind up in this. So winding up of wire will be there if there will be no gap in that. So that's why the commutator, which is exactly having two splits, that's why it is also called as split ring. So what is the other name of commutator? The other name of commutator is called as split rings. So there will be two split rings, so P and Q. So these two split rings are exactly connected to axle, and they will be rotating. Okay, they will be rotating. So once the split ring will come in this location, because when it will have half rotation, it will exactly, when it will not have half, 1/4 of the rotation, then the split ring will come in this direction. Okay, now once the split ring came like this, now what happens? The connectivity is exactly with the split ring is exactly going to stop, because now the carbon brush is exactly in this gap. the carbon brush is exactly in this gap. Then what happened? Then the ring will be, then this part will be rotating because of inertia. So inertia will be generated, and because of that what will happen? It will, because once it something will be in motion now and it is exactly freely moving, then 100% it will rotate more. Then once it will complete its rotation due to inertia, what will happen? Ki now after some time this C part will come here and D part will go that side. So now here A, B, C, D is there. Now what will happen? C will come here, D will come this side, now B will come here and A will come this side. Now tell me one thing. Now what will be the direction of flow of current? Now what will be the direction of flow of current? So what is the direction? What is the direction? So now the direction got changed. It is coming as CD and BA. The direction got coming, yes, correct only. Now everything has changed. Now it is exactly moving outside. Now it is what is exactly was there. Now it is totally converting 180 degree. It's not 360 degree. It's total 180 degree motion. And once, yeah. So now again if it is exactly moved, BC will come this side, BA will come this side and CD will come this side. When CD was here, then the direction of force was up and the direction of force was down. Now CD is here. Now for CD, one time when when CD was here, the direction of force was up, and AB, the direction of force was down. Okay, now next is when CD will come this side. Once CD will come this side, now for CD, in first case the direction of force was what? The direction of force was up. Now the direction of force will be down. Okay, and now for AB, which will take the place, now for the AB the direction of force is up. So once it will go 180 degree, means once it will exactly go more than this, then what will happen? The split ring will be freely attached with the wire. So what it will do? Downward, absolutely. So we have seen that anti-clockwise movement is there. Anti-clockwise movement is there. Along with anti-clockwise movement, we are seeing another important point is that it is continuously moving. Okay, one time will be there when the motion will be slightly stopped. So but that slightly stopped motion will be exactly forwarded due to inertia. Inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. So for some time it will have inertia, some time only it will have inertia, and then very next moment again this will exactly, the split ring will touch the carbon brush, and again continuity will be maintained. So that means it will exactly start rotating in anti-clockwise direction. Then one question is there, if magnetic field is here and it is influencing the magnetic field around it, and because of that the coil is exactly rotating, reverse aunty, yes, current reverse, but exactly beta, current reverse on the sides. It's not that the current is reversing from here. There is a confusion. Some children are having confusion because when they read the statement, they have a problem in understanding that current will be reversing. Beta, look at, the current will be flowing in the same time. The current flow will always be this direction and this direction, but the sides are rotating. So these two sides are there now. These two parallel sides will rotate, and there the force generation will be exactly different. So what happened when on AB the force was inward, CD the force was outward, now it will just go opposite. Now CD will have force inward and this one will be outward. So the current diversion direction reverse means on the side only the direction of current reverses, because when the coil will be like this, when AB will be there, then direction of current is this one. Okay, now CD direction of current is this one. Because when it will rotate like this, now CD will come this place. Once it will rotate 180 degree, CD will come this place, and now first just see, first CD direction of current was here, and now CD direction of current is here. This is called as change in direction of current. So when the phase will change, the direction of current for the phase will also change. The direction of current for the phase will also change, and it will be exactly moving anti-clockwise. I hope you might have understood this point. This is a very important point. Kamya, you are correct only. The direction of current change on the phase. That is a very, very important point. Yesterday night sample paper, they have asked the working of carbon brush and commutator. Can you tell me what is the working of commutator and carbon brush? Can you tell me the working of commutator and carbon brush? If somebody will be asking you what is the working of commutator and carbon brush, then what answer you are going to give? That is a very important question. Kamya, commutator periodically reverse the direction of current after each rotation. Very good. That is exactly. And next, Abhirami, to reverse the flow of current. Correct only. So reverse the flow of current in the rectangular coil. The work is to reverse the flow of current in the rectangular coil. Rahul, auntie, my doubt. What is the doubt, Rahul? Yeah, the split rings are exactly rotating and changing its direction. Now I have to show you another picture. You see here. Now the split ring will be rotating. You can see this part that once south pole will be there, then direction will be, force of direction is up, and this is exactly called as armature. This is called as armature. So that's why I just got the reverse picture so that you can understand that wherever north pole will be there, then you can see that force is coming down and south pole force is coming up. Here also we learned that here north pole was there, so force was down, and then south pole force was exactly up. So when this ring will just rotate like this, then now for this CD side force will go downward, and for AB side force will go up. Okay, and AD side force will go up. Yes, the split ring will also be rotating because split ring is connected. Split ring will be connected, beta. Split ring will be connected to the commutator. Split ring will be connected to the commutator. Split ring will be... Yes, beta. This is nothing but armature, beta. This is nothing but armature. The shape is exactly armature. Now one question is there. Okay, now magnetic field is influencing the sides AB and CD. Just 1 minute. Magnetic field is influencing the sides AB and CD. What about AD and BC? What about AD and BC? What about AD and BC? Magnetic field is influencing the sides AB and CD. What about the sides BC and AD? Is it going to influence that side also? Is it going to influence that side also? A very simple concept, because they may ask this type of questions. They may ask this type of questions. What will happen to that side? What will happen to that side? What will happen to that side? One simple concept here, yes, magnetic field is influencing this sides because here the magnetic lines of force are intersecting each other. So the magnetic lines of force, the moment the magnetic lines of force will be perpendicular to each other, they will be creating problem. But here the magnetic lines of force will go parallel. These faces, the magnetic lines of force will go parallel. It will change these side BC and AD. The magnetic lines of force will go parallel. So because of that, it is not going to create problem that side. The problem here is this one. See, when magnetic lines of force will come in the field of another magnetic lines of force, then only they will be exactly influencing each other, or they will be repelling each other. So this movement, this is exactly going to create a type of rotation. Okay, so one magnetic field influencing the other magnetic field. So the repulsion between them will create motion in the rectangular coil. The repulsion between them will create motion in the rectangular coil. Now the another thing is, when you see this side, the direction of current flow is this one, and the magnetic lines of force are going like this. So what they are doing is, they are not going to influence them, because they are not going to be intersecting the magnetic lines of force. So here there is no problem, but the problem here is in this phase. So 100% that problem is good for us, because what it is having is, it is exactly influencing the field of each other, and that's why it is exactly rotating like this. So now that means, if this is the blade and this is my AB side, then this AB side force act downward, it moved like this, and then due to inertia it rotated like this. Once it came like this, now what happened? The moment it came like this, this thumb was that side, now the thumb came this side. Now what will happen? Because force will again take it down, again it will rotate like this. So that means it will have a continuous rotation like this, and every time it will be exactly rotating. Every time whenever it will come this side, whenever it will come the north side, the force will act downward. Okay, so this is north side, and this is exactly the face, and north side, and this is the face, and current is passing like this. Current is moving in this direction. So what will happen? It will just rotate like this. And now for this phase, the current flow was like this, and this phase the current flow was like this. But after rotating, now this place will not be B, this place will become C, because you see my thumb was first here and now it is here. So this C side, this C and D side, now initially the magnetic force was exactly up, now the force is exactly going down. Now for CD, what direction was there, now the direction got reversed. The direction of current is exactly reversed. Now come on, quickly tell me anything. Madhu, you understood any concept related to it? Any concept related to it understood? Anything you all have understood? Anything? So split ring, carbon brush, we know that the work of it is exactly, first work is lubricating and second work is electrification. The work is lubrication and electrification. Yesterday itself night we were discussing about it, about carbon brushes. Kame understood na beta? Just remember, the sides are getting reversed, the direction of current is getting reversed. When the sides will get reversed, the direction of current will get reversed, because once the side was CD, the current direction was this one and force was this. Once it turned, now the correct direction exactly changed. The current direction exactly changed, and this one will allow it to move. You don't have to write big stories, just write the working very technically. You have to say this point that when the current will pass in the wire, it will generate an electromagnetic field. So this will have its own electromagnetic field, and this electromagnetic field is influenced by the magnetic field generated by north and south pole. Okay, and since they are influencing each other, so and the magnetic lines of force are intersecting each other, and we know that magnetic lines of force should not intersect, then what will happen? It will create a repulsion, and because of that it will start. Yes, what is electrification means? Giving electricity. You might have seen that the carbon brushes are attached to split ring. And the split ring is exactly, you see here, the split ring is exactly attached. So the split ring is attached to the wire. So the main connection of the wire is with the split ring. Okay, so the split ring will rotate. Okay, the split ring will rotate, and it will rotate the coil also. But the carbon brushes are carrying current. So it is the work of electrification. It is, what is the work it is there? The work is to electrify and lubricate also, because until and unless there will be friction. So carbon brush and split ring, if they will be having friction, then it will exactly lower the speed. So we have to reduce the speed. So we know that it is mostly graphite, and the work of graphite is they are good conductor of electricity and they work as a lubricant. Okay, they work as a lubricant. So that's why carbon brushes or these brushes are exactly why called as carbon brushes, because they are mostly graphite. Remember these points. Why we called it as carbon brushes? Because X and Y are carbon brushes here. So this X and Y are carbon brushes because they are made of, mostly they are graphite. Now what is the work of graphite? Graphite is a good conductor of electricity. Next important point is graphite acts as a very good lubrication. Okay, so it will reduce the friction so that the rotation of the split ring will be very fast. I told the basic points of it, no book content. I could have showed you the book and I could have told you the line by line content, but I told you the most basic things that you have to write there. So all as a key point you have to remember. All has a key point you have to remember. First key point, last time I am explaining. First key point, point by point, I discussed the points. Okay, so what did I said? Split ring will have a gap. That's why it is called as split ring. And its name is commutator. It is connected to the rectangular coil. The rectangular coil is exactly called as armature. After that we learned that there is a direction of flow of current. Now from the north side, the direction of flow of current means if this battery is connected to this side and the battery positive terminal is coming, so current will flow like this. So once the current will flow in this direction, then what will happen? According to Fleming's left hand rule, here no other rule, Fleming's left hand rule. Fleming's left hand rule will tell you that direction of force will be down. Magnetic lines of force will go like this. This magnetic lines of force generated by the magnet will allow the current moving, the direction of motion of the current creates a force, and the force will be exactly downward. You see the arrows, you will come to know the force will be acting downward. Now the direction of current is exactly opposite. Now in the other phase, the the other side, the direction of current is exactly opposite. The magnetic lines of force is going this side, current is exactly coming this side. So this time the force will exactly go up. So now it will, the moment it will be like this, the moment it is going to intersect, the split ring will rotate, and once it will half rotate, what will happen? This will go to this carbon brush side. So that time, for some time, the speed will become slower, but due to inertia it will maintain its motion, and then it will go directly 180 degree. Once it will go directly 180 degree, now the C side and D side will come. Now first C and D side have force outward. Now the force will exactly change. Okay, the magnetic field lines, diagram drawing is very important. Yeah, nothing is there. Even me, person like me can draw. They make two holes like this and just one commutator like this. See, the person who don't know how to draw, who is that person is drawing. This is carbon brush. See, this is carbon brush connected to it. Okay, so we need a commutator, we need a carbon brush, we need an axle, and then this what you call split ring will be connected to like this. Okay, and here north pole, here south pole, and this is connected to cell. See, I know you are not understanding anything. It's the aliens drawing, but you draw better than me. I know that. Yeah, mostly they will give itself the picture because they will be asking 4-mark question. Nowadays they are not asking drawing diagrams, because initially they were asking draw this, draw that. Now in the working section they are not asking that much. Okay, they are not asking to draw because they know, but any day can be a rainy day. I told you again and again, any day can be a rainy day. So you can see that split rings work, and split ring connected to carbon brush, commutator segment is there, battery is connected. This is the very primitive picture. So now you see simple example, the simple device here, and see here north pole is exactly there, south pole is there. Then the direction of motion will be, see, if the current direction is reverse, listen to me, if the current here, the current is moving from this side, sorry, the current is moving from this side, and south pole is there and north pole will be there, then force will be just opposite. You have to pick this point very nicely, and that's why with one picture I cannot hold. So only I have taken 2-3 pictures so that you can understand it. So when current is moving in this direction, then force inward, north pole, current this direction, force down. Okay, now look here, North pole is here, but current is moving in reverse direction. Here exactly current is moving this side, south pole is there. So when current is moving this side and south pole will be there, then force will be up. Force will be up and it will move clockwise. It will move clockwise. It will move clockwise. This is a very important point to remember. So only I gathered different pictures so that you can understand what is the basic difference. It is not only anti-clockwise motion. Please don't think like that. You have to see the alignment of the magnet also. When picture will be given to you, when they will give you the image figure, that is exactly a trap for you. You have to understand that trap. By seeing that picture, you have to analyze it perfectly. You have to see that, okay, south pole is here, then direction of current is here. South pole, that means now the motion of field lines from north pole to south pole will come like this. Okay, so that means just 1 minute. That means that particular moment, the direction of flow of that force exerted will be up. Force exerted will be up. It will just be direction. One more time, do with a pencil, draw and try to know the direction. Okay, current going, look here, current going this direction, south pole here. So magnetic lines of force coming this direction, that means force is coming up. Okay, force is coming up. This is the most important point. So there they will confuse you by keeping the magnet in different location. So if they will keep the magnet, so both the picture, that's why I kept, because I don't want my children to get confused. So if north is here, south is here, current moving like this. Simple concept. Just now it's the point to pick content. Okay, it's the time to pick content, beta. North is here, south is here, magnet current is going like this. Okay, so now what will happen? Force will be down. Force will be down. This is first thing. Force will be down. Force will be exactly down and opposite force will be up. So this is exactly anti-clockwise motion. This will generate anti-clockwise motion. This will generate what type of motion? Anti-clockwise direction. This will generate anti-clockwise motion. Now here clockwise motion is also possible. Now here clockwise motion, how clockwise motion is possible? Check this one out. So here again current is going this direction. But here rather than north pole, south pole is there. So current is moving in this direction. Now magnetic field lines is coming like this. So this time it will go, force will be up. This time force will be up. Come on, quickly tell me. And this time the motion will be exactly clockwise. The motion will be clockwise. The motion will be clockwise. So will you tell me that did you understood this point? Okay, so in simple, first we will go out of this track and first we will make a plan. Plan is what? Our plan is when north pole of the magnet will be here, current will go up, north pole, current, force down. Okay, now this one, current this direction, force up. So join the arrow. Anti-clockwise. Join the arrow anti-clockwise. Okay. Now here south pole, current going up. North pole this side, current going down. Current is going from south pole. Starting from south pole, current is going up. Now here exactly the force will be opposite, it will go up. So if force is up, this force will be down. That means join this arrow clockwise. Now come on, give me an assurance you have understood. Madhu understood? Madhu understood only for this you need one thing. North with arrow up. North with arrow up. Just you know one thing na, like east, west, north, south. Remember like north, north pole. Like this remember. North, north pole, go to south. North, north pole is always up na beta, go to south. Means force is exactly, movement will be this direction. Okay. Now here opposite will work. South, south pole, go to north. So that means now force is here, force is up. So it will rotate anti-clockwise. Now my children are very silent. Did they understood anything or not? I don't know. I don't know beta you have understood or not. If you want, I'll explain. Nothing is there in that. What happened? No comments, nothing coming. Any doubt is there, beta, you can ask me quickly. I'm going to explain because some questions are also there. I want to discuss that questions, or I'll send the PDF. Mathivan understood, beta? Very good. Tawfiq, you just have to see this part of the video one more time. But here I just need to let you understand, Tawfiq, one simple thing, beta. See Tawfiq, big explanation. No, I am going to give you the most important key points to remember Tawfiq, so that when you will be writing in examination, you will not do mistake. So the key points are here, beta. What are the key points, Tawfiq? Now understand it nicely, beta. When south pole will be there, Tawfiq, south pole will be there, current will go towards north. Okay, south pole is here, current is going towards north, then force will be up. Okay. So that is what I have drawn that one. Okay. And when the north pole will be there, current is going out towards south. So you see there is a game of south and north. There is a game of south and north. You just remember this point. Here the current is going towards north direction. South pole, north direction. South, north, force up. Okay, beta. Now here, Tawfiq, look here one more time, beta, very nicely. The current is exactly moving towards north, south means geographical south. Okay, and here north pole is there. That means force will go down. Force will go down. Force will go down. Like that, beta, the picture I have shown now, that picture only one more time, Tawfiq, remember, that is here magnet north, current going towards north direction. Magnet north, current going towards magnet north, current going towards north direction, current going towards north direction, and beta this is south. So now you see current is exactly going from going to north direction. This is north pole. So north, here you just say that force is down, force is down, force is down. Now in the opposite part you will see current is exactly going towards south. This will be south pole. Okay. Now here north, current going up, force is going down. South, current going down, force will go up. Force will just follow reverse. Force will just follow reverse and it will go. So beta, now force is exactly going like this. Tawfiq, look my finger, beta. It will exactly move like this. So the motion will be from up to down. So it will become anti-clockwise. Tawfiq understood, beta? Quickly say so that I can go to the next point. Now here south will be there, Tawfiq, but the current is moving towards north. South, but current is moving towards, I didn't change the direction of motion of current. Okay, so here south is there, current is going up. For here north is there, current is going north. Here south pole is there, current is going up. Then south pole current going up, that time the force will be opposite, this time it will go up. And here north pole is there. Now the wire, it will exactly down, the current is going south. South north means now it is exactly going to go down. So the rotation will be clockwise. So the rotation will be clockwise. So this now beta, just remember it as key point. And then you have to remember the key point for carbon brush. Carbon brush beta is exactly that brush which is made, it is not a brush exactly, it is a graphite brush. Okay, so it is made with graphite, that's why it is called as carbon. It is having two work. One work is lubrication, another lubrication means it provides necessary what you called motion, because it reduces friction. Next is, it is exactly having, it is allowing current to pass, and it is connected to the split ring, so that the split ring will have current on it, and the current will pass from via split ring to the armature. Okay, via split ring to the armature. So now one very important thing is there, direction was very important. This PDF I am going to send to you. Now one questions like this, they will ask now, you will really feel exhausted when they will ask this question. Now that's why I have just captured this question for you, so that you can, because magnetic field means direction will be specific. So this PDF I am going to send to you, so that in home before examination one time you can read. Imagine that you are sitting in the chamber with your back at one wall. So this is the back wall. Okay, this is the back wall, and you are sitting in a chamber. An electron beam moving horizontally from back wall towards the front wall. So now from back wall, the electron beam is moving. The electron beam is moving, is deflected by a strong magnetic field lines. Now it is exactly deflected by strong magnetic field lines to your right side. See, this type of question, when accidentally also they will give this question, this question will be a big problem. So what is the direction of magnetic field? What will be the direction of magnetic field? So electron beam is coming outward. This is the front wall, this is the back wall. That means you are facing this side. An electron beam is moving this side. So 100% electron beam will move this side. That means current will move this direction, because we know that direction of motion of current, we are taking opposite to the direction of motion of electrons. So if current will move this side, electron motion is only constituting current, but by convention we know that it will exactly go opposite to that. So here if it is electron, then current will move this direction, and if current will move this direction, then the field line will be exactly, and magnetic field, they are saying that the magnetic field is exactly in your right side. So magnetic field will be generated in your right side. So if magnetic field is generated in your right side, so if you are sitting here, then magnetic field will be generated in your right side. Electron is moving here, so current will move this side. So where will be the force? Here magnetic field towards your right, current will be there, then that means force will be down, force will be down, force will be down. So this is a very important question. Like this question, if they will ask, I want my children to be the first one to answer such questions. Okay, so now next question is, because I want to handle, see, look here, this type of picture also, you look here, Rahul, you were asking the split rings are moving or not, motion will be there, that also I have explained. See, principal construction working, this is the most shortcut answer there and simplest one. If you will read once, you will be able to understand. With the help of diagram of experimental setup, described an activity to show that the force acting on current carrying conductor placed in a magnetic field increases with increase in magnetic field strength. And this, they will ask this question, means it will be a trauma. The reason behind I am calling it as trauma, because that time you have to explain it in your own content. Then you have to create a total setup. You have to write aims, you have to write apparatus, you have to write procedure, and you have to just write the steps there. And then you have to write observation. So that's why this question, one time I wanted to listen to me, what they are asking, that with the help of a diagram of experimental setup, okay, describe an activity to show that force acting on a current carrying conductor placed in a magnetic field increases with increase in field strength. Then you have to say that to show that force acting on current carrying conductor placed in a magnetic field increasing with the field strength, we need an apparatus required. So what we are going to do, we will be taking an aluminium rod. Okay, in that aluminium rod, a clamp stand, a horseshoe magnet, of different intensity, cell key and connecting wire. So these are the apparatus required. After that procedure, arrange the experimental setup as shown in the figure. That time figure will be important. What you are exactly going to do is you are going to draw it very nicely. So just one experimental setup is very needed, and you should have a rough sketch of that. So only I have taken this picture. Plug the key. The moment you will plug the key, what will happen? This one experiment like this you can show, another experiment is also there. So when you will switch on the key, what will happen? It will give up setup current, which will be exactly passing from rod Q to P. The moment current will pass, what will happen? Magnetic field lines will be generated. So magnetic field lines will generate around this because this is connected, this rod is connected to electricity. The setup is very simple here. This is exactly the connecting wire and this is the rod, and what they did is they kept magnet near it. So, and that is horseshoe magnet. Now what happened? The current will start moving into this rod. Once the current will start moving into this rod, what will happen? From positive to negative terminal, you can see positive terminal is here. So it will go like this. The current motion will be here. Once the current motion will be here, the magnetic field lines will be exactly generated around it. Then force will be in this direction. And this magnet, horseshoe magnet, will also have a force. So what will happen? So now the moment it will be there, then what it will do? It will start repelling each other. So now then if you will do it in different directions, so one time it will attract. Yes, write in short point was, they have done this much description. You write point by point, beta. You don't go to that much details. You just, your basic idea should be for 4 mark. If they will ask this type of question, your basic idea should be aims should be covered, apparatus should be covered, what apparatus you are going to set up, what apparatus you are going to set up, that setup should be there in your brain. Procedure you are going to write on your own words, and last observation. The observation point is the most crucial point, because what in the question they have asked, you have to claim that point. Okay, that is in each time conductor moves faster than that of previous one. It is possible when conductor gets accelerated. So, and it is exactly requiring more force. So, every time it will be exactly kept on increasing the force. Okay. So, this conclusion also will be there in your hand. You have to write in short. But I don't know what type of question will come. But why to leave a stone unturned? Means when we know where we are standing, that time we should be not giving any point to anyone. So that it is a matter of 4 mark. Okay. So only. Now, direction of current, what happened, this PDF, the moment I am going to just because time is there, 7:30 it's starting, so I cannot go after that. So this PDF I am going to provide it to you now only, so that beta you can right now itself start reading this PDF. There are some directional question. Definitely this question I am going to discuss in revision classes. So these questions will be revising in revision class, but right now you need this question more than me. Okay, so rather than keeping it with me and discussing it, I really want you to right now revise these questions. So one time revise these questions. Okay, so I'm going to keep it till here. So now these questions I'm going to send it right away to you, so that you can revise these questions. Okay, all the best to everyone. These questions one time go through, beta, go through, because magnet na, every time they will not ask magnetic field, this thing, that thing, forget about it. You have to if whatever question they will, good morning CP, so understood or not? So I'm just keeping it till here, beta.